Can you see the pattern? All right, so what we're looking at here is we're looking at, can we find the fourth figure in the sequence based on the first couple of patterns? Well, the first one is 1 by 2, and erasers don't write. The second one is 2 by 3, 3 by 4. So the center section should be 4 wide, so there's 4 wide, and 5 high. So that should be the center section. And again, that just covers these right here. And what else do we have? And then we have the single pieces there. So there should be your center section. If we go ahead and we look at the figure number and the number of blocks. So figure 1, 2, 3, and 4, that's what n represents. F of n was 4. So 2 by 3 is 6, plus 2 is 7. 3 by 4, 12, plus 2 is 14. 4 by 5, which is 20, plus 2 is 22. And what do we get a difference of? We get a difference of plus 3, should be plus, oh god, I'm drawing a blank. Gee, I need to go back and double check that because that doesn't seem right. 6, 7, 8. No, I was off on that. That should be, so plus 4 plus 8. That's how I know that's wrong. The differences didn't add up here. So plus 4. 8 plus what is 14? Plus 6 plus 8. And that's a difference of plus 2 and plus 2. So now we need to come up with the explicit and recursive equations. Well, the explicit equations are not as difficult as they seem if we look at each figure and look at what is happening. We already know that it's plus 2 plus 2. So I'm going to put my focus solely on this center section right here and see what happens with that. I already know I have to add the 2 at the end, so I'll just put that right there. Yes, I know that's going to go down here, but give me a second. Well, originally my first figure should be 1 by 1. It's still 1 wide, but what happened to its height? Its height increased by 1, so it should be 1 plus 1. Figure number 2 should be 2 by 2, but how is it increased? It's 2 plus 1. Figure number 3, 3 by 3 plus 1. So as you can see, it's adding 1 to the height every time. So if I look at it as a length and a width, or a base and a height, my base has stayed the same. So f of 1, now we can just go ahead and put it down here. So my explicit equation is f of n is equal to my base, which is n for any given figure number. Notice 1 is 1, 2 is 2, 3 is 3, times, how did the overall height change? N plus 1. And then what did I do at the end? Remember at the end it was always the add plus 2. Recursive equation. Recursive equation is pretty simple. F of 1 is equal to your first value, which is 4 in this case, not 7. That's 4. Change it to a 4. And then f of n is equivalent to what? F of n minus 1. And this is where we get that mx plus b look, which, where does the m come from? The m comes from my constant second difference, so plus 2. The x is whatever variable I use right here, which is actually n, right? X would be my input, that would be over here. Well, in this case, it's n, if I were to go up there and look. And then plus b. This comes from, what did I do to get back to the y-intercept? Well, where is the y-intercept? If this is plus 4 plus 6, then it would be plus 2. And then before that, it would be plus 0, right? So 4 minus 2 is 2. I don't care about what goes on before that. I don't really care. I want to know what I did to get back there. So I added 0. So there's that. And then if you're counting the sum for the number of equations in figure 30, use your explicit equation. So f of 30 should be equal to 30 times 30 plus 1. So 30 times 30 plus 1 plus 2. And that'll give you the total. Moving on to the second one. We can see the second one in several different ways. I'm only going to talk about it Well, I'm going to talk about it kind of in this way. All right. Again, there's several different ways, but I'm just going to mention one of them just for the sake of the video. I'm looking at this as a perfect square. This square here should be 1 by 1, but it's not. It's 1 plus 1, as I write 2. It's 1 plus 1 times 1 plus 1, as I write 2 again. I'm just thinking of 2. That's why I'm writing 2. This one here should be 2 by 2, but it's 2 plus 1 times 2 plus 1. This should be 3 by 3, but it's 3 plus 1, so it's overall 4. So change the mindset of how you see it. It should originally be a 3 by 3. Well, that's what the figure number. So over here, you should be able to pause and draw the fourth figure in the sequence. All right? We should be able to determine the number of figures, 1, 2, 3, 4, and the number of blocks in each figure. Okay? 4 plus 3 is 7. We've got 3 by 3, which is 9, 10, 11, 12, 13, 14, 15. Is that right? 3 by 3 is 9. 9 plus 9, 10, 11, 12, 13, no, 14. Figure number 3, again, fill those out. You should be able to fill that out. All right, so my first difference is plus 7. So I'll finish filling it out and come back. You should have plus 9, plus 11, plus 2 is the second difference. So when we get to the recursive equation, that's going to come in handy. All right, that will come in handy. But now, what about the explicit? Well, the explicit shouldn't be too bad. You're used to seeing a 1 by 1 square, but that has changed. My focus is 1 by 1, and I have some extras. So my base is going to be the nth figure plus 1. Nth figure plus 1. Nth figure plus 1. So that's my base. My height is going to be the same, n plus 1. So there's my length and width, or base and height. It's the same thing. And then I have this other stuff that's going on over here. Well, what do you notice that's happening over here? What I notice is it's plus 3, it's plus 5, it's plus 7, and if you count over here, it's plus 9. So what do you see? 3, 5, 7. That's a difference of 2. That's a difference of 2. So one way to look at this is the extra squares, remember again, that's this focus right here, is a linear rate of change. So how do we express linear rates of change? Well, 2n, okay, so n is the figure number, multiplied that by the common difference, 2, but that only gives me 2 of the 3 squares. I need to add 1, and that gives me the total for all 3. But will it give me the total for all 5? Well, remember, you're putting the figure number in here. So 2 times 2 is 4, 4 plus 1 is 5. 3 times 2 is 6, 6 plus 1 is 7. So yes, it works. That linear look essentially is it. So here is your explicit equation. All right, you can just go ahead and copy that down in there. And then we'll look at the recursive if you need to pause and do that. The recursive should be f of 1. So pause me if you need to and come back. F of 1 is 7. So f of n is equal to f of n minus 1. And then, again, we got the mx plus b thing. Well, here's your mx plus b. Here's your 2n. Remember, we're replacing the n with the f. And then, what do I do to get back to the y-intercept? What do I do? Well, 0. So if it's plus 7 plus 9, it should be plus 5. So 7 minus 5 is 2. And then it should be plus 3. Plus 3 is what I do. So plus 3 right there. We'll have some more exercises about that later. And then you can go ahead and use your explicit equation to fill that in and find the number of blocks. Make sure you do so. And if you struggle with this, please ask questions.